derivative tells you the instantaneous slope or rate of change. Let's just leave it at that. So I'm going to start doing some examples, and then we'll kind of formalize it into like rules that you can use. So if I have y equals 3, what is the slope of, let's back it up. What kind of line is that? Don't say straight. Horizontal? I'm not physically doing it actually. So what's the slope of a horizontal line? 0. So if I had y equals 3, my derivative, and this is how you'd represent it, y prime would be 3, or I could have given you like f of x equals 3, and you would say f prime, this is 0, sorry. Or you would say f prime of x equals 0. And it's just slope. So you don't need calculus to find the derivative of a line, because you know how to find the slope of a line already, and the derivative is just the slope. So, I give you y equals 10 squared. I don't know why it'd be written like that. But it could be, what's the slope of that line? That would just be y equals 100, which is what kind of line? Horizontal. So what's the slope of a horizontal line? 0. Or again, it could be f of x equals 100, f prime of x equals 0. Moving up a level, and what I mean by that is like adding a variable, adding a power of x. So let's say y equals 3x minus 7. Or, I could write it as f of x equals 3x minus 7. That's a line, right? What's the slope of that line? 3. So therefore, what's the derivative? 3. And isn't the slope the same the entire time? When you're at a line, whatever the slope is, the slope is the same the whole time. When we get into curves, does the slope stay the same the whole time? No, and that's what calculus is for. So I don't need calculus for this necessarily, but I can. But that's, yeah.
Last year in Miss Main's class, she has doing something where like she took the exponent multiplied by the number.
It's coming, hold on. I'm getting there. I'm building my case. So let's say, y equals negative 1/2 x minus 5. That's a line, right? What's the slope of that line? Negative 1/2. So what's the derivative? Negative 1/2. Okay, so let's do the rule that you were talking about. So the rule, then you get into powers. And if it's a power, like if I have y equals x squared, is the slope the same the whole time? No. So the slope depends on the x value. So if I'm at, if I have y equals x squared, if I'm at like x equals 2, is my slope positive or negative? My instantaneous slope positive or negative? It'll be positive. But if I'm at x equals negative 2, is my instantaneous slope positive or negative? Negative. If I'm at x equals 0, what's my slope? It'd be 0, wouldn't it? Because that's like right where it turns around. So we have to find a way that would take all that into account. The derivative here, so what you're talking about is you take the power on top, you bring it down, you multiply by the coefficient that's in front. In this case, there's not a coefficient, there's a 1, right? So you do 2 times the 1, you leave the variable, and then you reduce the power by 1. So this would be 2x to the first, or just 2x. And then I can use this, and if I look back over here, so this tells me the slope, the instantaneous slope at any point on the graph. So what's the slope of y equals x squared when x equals 2? It's 2 times the x value. So the slope here is 4. If I said, what's the slope at x equals 0? It's 2 times the x value. So what's 2 times 0? 0. Doesn't that make sense? We got a horizontal line there. What's the slope at x equals negative 2? 2 times negative 2. So negative 4. That makes sense. We got a negative slope that's like the same number. You know, it's symmetric. So we got 2 over here, negative 2 over here. So the power rule is if you have y equals k times x to the n power, the derivative, which again tells you the instantaneous slope, is you bring down the n and you multiply it by the k, you leave the x, and you lower the power by 1. But that looks way more confusing than it is. Like, you got n, k, and there's just a bunch of variables there. It's not that complicated. And it does apply to the earlier examples I gave you. Even though you don't need calculus for that, it will work in those scenarios also. So just a few quick simple examples here. Let's say y equals 6x to the third. It's way zeros numbers, unlike the n, k, and minus 1 thing. So you take the power, you multiply by the number in front. So 3 times 6 is 18. Write down the x and you lower the power by 1. So that derivative would be 18x squared. What does it mean? If I ask you to find the slope of that line when x equals 1, or this is not a line, this is a curve. This looks like something like this. Find the slope of this equation when x equals 1. What would you say? It'd be 18. You plug 1 in here, 1 squared is 18. And this is a really steep one. It'd be like over here. This does get really steep really fast because that's 6. So your tangent slope or your instant slope here would be 18. Y equals 1/2 x to the 10th. So your derivative would be take the 10, multiply by the 1/2, get 5, leave your x, reduce your power by 1, so 5x to the 9. And then I could say, what's the slope at x equals 2, x equals 10, x equals 0, whatever, and you would just plug in and tell me that. I want to go back to the ones we did before. So I gave you like y equals 3 was the first one. If I said what's the slope, you could just think in your, okay, that's a horizontal line, the slope of any horizontal line is 0. And you could do it that way. But I want to show you that the power rule does work in this case. Could I write this 3 as 3x to the 0? So x to the 0, anything to the 0 is really 1. So this is a fair way to write this. And some people will write it to show like this has 0 x's in it. As I go up the level, but I have 1, like x and then x squared. So this is x to the 0. Well, if I follow through this rule, bring down, so take the power, multiply by the number in front. What's 0 times 3? 0. Reduce the power by 1, that doesn't matter anymore, because what's 0 times anything? 0. So we knew the slope was 0, but I'm just showing you that power rule does work in this scenario also. Same thing with, if I had like 4x minus 2. What's the slope of that line? Oh, so the derivative better be 4. And does the slope depend on the x value? Or is the slope the same the entire time? The slope's the same the entire time. So our derivative better be 4 the entire time, which means there can't be an x. So this is 4x to the first, right? So bring down the 1, multiply by the 4. Leave the x, reduce the power by 1. So where am I at now? When I reduce the power by 1, it's 0. Minus, and then I just do the same thing for this. Well, I just went through this. What's the slope or what? So now you just gotta look at that part. What's the slope of y equals 2? Or what's the derivative of 2? It'd be 0. Which looks way complicated, but isn't that just y equals 4? Or y prime equals 4? So again, I'm just trying to show you the power rule works even in those situations. You don't need to use it there, but I'm just trying to show you that it does. Alright, let's say I had y equals x to the third minus 2x squared plus 4x minus 5. And I asked you to take the derivative of that. It's just 4 separate derivatives. If you have functions being multiplied or divided, we get into power rule and quotient rule, and that's a different ballgame. But for something like this where there's not a big multiplication or division, you just look at it like term by term. So I got 4 terms here. I'm just going to take the derivative of each one. So what's the derivative of x to the third? 3x squared. We all see how I'm getting that? So I'm taking the 3, multiply by the number in front, which is a 1. So 3 times 1 is 3. Write the x, knock down the power by 1. Minus 2 times 2 is 4. Leave the x, reduce the power by 1, so it's just 4x. Plus, what's the derivative of 4x? 4. Minus, I don't even need to write it, because what's the derivative of 5? 0. This would be your derivative. What does that tell you? What does the derivative tell you? Instantaneous slope at any x value. So what's the slope of the original equation at x equals 0? Stick 0 in here. You would know that the slope is 4. What's the slope when x is 1? You plug 1 in here, you know the slope is 1. And it changes depending on the x value. So let me give you a few kind of simple ones, and then I'll show you where the difficulty comes in. Those 4, that's good. No, that's a lie. I'm gonna add a couple. I put 3 more up there. If you so there was the 4 I wrote originally, but I just added 3. Make sure you see the 3 I added too. Same idea, just letters instead of numbers. Someone sit there, or is that always empty? Oh, that's Knowles, right? You're back there. Okay. But then Cece's usually there, but Cece's over there. She goes. Okay, so what's the derivative of 8? 0. What's the derivative of 6x? 6. Derivative of 4x squared? 8x. This you're just doing, it's like 2 separate problems, basically. So 25x to the 4th and then minus 3. Let me get those first 4 right. So that's with numbers, and then like can you do it with letters is all I'm doing down here. So if y equals any constant, no matter what, what's the derivative? 0. If y equals any constant times x, and I could even put like plus c out here, it wouldn't matter. What's the derivative? Okay. And then this would be like t times m times x to the t minus 1. Questions on any of those 7? We talked about the 7 seconds. So that's the calculus. That's not the hard part. And that's a very common thing in this class. Because now we gotta do it with something like that. The rules don't change when you have to deal with fractions and negative exponents. So the first thing I would do in a problem like this is rewrite it. You don't want any radicals in there. So I'm gonna get rid of that like third root. And you don't want variables on the bottom. This 2/4 is bothering me because it's not a reduced fraction. Make it 21/4. Did you just say I'll just leave it? You would? Yes. So I'm going to get rid of this radical. So is that x to the 1/3 or x to the 3/1? 1/3 because you got the inside over the outside. So I'm just rewriting. I'm not putting that prime thing in yet. I'm not taking the derivative yet. I'm just rewriting the original problem in a form that's going to be easier for me to take the derivative. Plus, now people mess this up. This 21/4 is a fraction that's locked into place. The 4 is not going to come up. We need to bring the variable up because I don't want variables in the bottom. So when I bring the x squared up to the top, it's going to become x to the -2. I'm going to write it like this. But that 4 is still down there. You can't bring the 4 up unless you make it a 1/4. But then it just becomes messier. And then if you brought it up and made it 1/4, what's 21 times 1/4? You end up at 21/4 anyway. So don't try to bring the constant up. Constants stay where they are. The variable can't be on the bottom. And then this last one is actually fine. I don't need to rewrite that. So let's take the derivative. So there's not a new rule. It's just now we have fractions involved. So I'm going to take the 1/3, bring it down, multiply the number in front. So 1/3 times 1 is 1/3. And reduce the power by 1. So I'm doing 1/3 minus 1, which, is like 1/3 minus 3/3. So that becomes x to the -2/3. It's actually going to be minus, not plus. Take the power, multiply by the number in front. Well, now we got to deal with fractions. So this is like -2/1 times 21/4. When you're multiplying fractions, you just go straight across the top and straight across the bottom. So this is 42/4. And you are allowed to reduce it, but there's no gain in doing so. So you can also just leave it. Unless it's multiple choice and you have to match it up. X to what power now? If I reduce the power by 1, -3, right? Not -1. Because you got to subtract 1. And then same idea over here. So I'm going to bring down the 4/5 times the 1/3. Well, you do top times top and bottom times bottom. So that's 4/15. Reduce the power by 1. So 4/5 minus 1 is like 4/5 minus 5/5. So -1/5. And this is an acceptable answer on a free response. If I gave you a test and had here take the derivative, that's an acceptable answer. But they might, on a multiple choice, get rid of negative exponents. So to get rid of a negative exponent, what do I do with the variable? Flip it, right? Flip it to the bottom. So if I had to, I would rewrite this as 1/3x to the 2/3. So again, the fraction is locked in place. 1 on top, 3 on the bottom. That's locked. We can move the variable back and forth by adjusting the sign of the power. They would probably make this over. They would probably go back to 21/2x to the 3rd. Again, you're not responsible to do that, but do you see how these two things are the same? 42/4, if I reduce it, it's 21/2. X to the -3rd on top is x to the 3rd on the bottom. And then they would go, okay, 4/15x to the 1/5. there'll be times when they'll leave the answer like this too, with the negative exponents. So you don't have to take this extra step, but there'll be times when they change it. So you gotta be able to adjust either way. And so the calculus wasn't the hard part of that at all, right? Multiply and subtract, like that's the calculus. That's it. But when it's fractions, it gets a little tricky. Questions anywhere on that I can answer? Yeah.
Will they ever reduce the x to 2/3, the cube of x squared?
Yeah. So you're saying could they write it like this? They could. They're a-holes, so who knows what they're gonna do. But if I did that, so do you see how these are the same? This one wouldn't change, so this one I could do that. So that's just another way they could mess with you and like, hey, put it in our form, jump through all of our hoops, do it our way. Same problem, kind of could write the answer 3 different ways. I don't see that one very often though, but they could. Anything else on that one? Do that one. And I don't care how you leave your answer. Oh, thank you. This class is hilarious. I've never seen it. Seriously looks like a bunch of tourists. We're all gonna go see the Statue of Liberty in a second. You alright, Worth? Good to hear. When you rewrite it, don't put that prime sign yet, because you haven't taken the derivative yet, remember? That's just my rewriting step. So if you want to check like your first move there, that's what it should look like. The Q would be a 1. This? No, so when I bring it up, the exponent flips sides. I think you're thinking of like the root radical. So your derivative would be bring down this 2/5. Well, first of all, are there any questions on the rewrite? Okay. Bring down the 2/5. leave the x, reduce the power by 1 would give you negative 3/5. If I were going to rewrite that, it would be 2 on the top, 5 on the bottom, and then the x to the 3/5 on the bottom. You didn't have to, I'm just showing you. Negative 3 over 1 times negative 3 over 2 would be positive 9 over 2 x to the negative 4th. If I were going to rewrite that, it would be 9 over 2x to the 4th. Question on those first two terms. The third one, so you got 1/4 times 1/5. Top times top, bottom times bottom gives me 1/20th. X, reduce the power by 1 would be negative 3/4. If you were asked to rewrite it, 1 on top, 20 on the bottom, and the variable with the power would flip to the bottom. And I didn't ask you to do this, I'm just showing you both. But how many had this answer? Nice. Questions on it? Alright, so you got your homework. I think you can see the calculus is not the issue. It's all the algebra, fractions, all the moving stuff around, all that stuff that gets kind of bogs you down. Calculus is easy.
On the homework, how much of the, or which form would you like us to write?
I think the answers have both forms.
Like all three?
No, just 2.
Okay.
But either one of those is fine by me. Fair enough?